Question 14. Here are some cards. Each card has a letter on it. So you've got A, B, B and C. Rachel takes at random 2 of these cards. Work out the probability that there are different letters on the 2 cards. Now you don't have to draw out a tree diagram, probability tree diagram, but I'm going to show you exactly what's going on. Okay, so she's going to take 2 cards. So the first card she gets can be an A, a B or a C. Now probability of an A is going to be 3 out of 6. Probability of a B is 2 out of 6, and probability of C is 1 out of 6. Okay. Now, if she picks an A first, she could also get A, B or C. Now, if she had picked A first, now she's got 5 cards to choose from, and as she's already chosen an A, only 2 out of 5 is going to be an A for the second choice. For the B, if she picks A first, she's still got 2 out of 5 is going to be the B, and if she picks A first, she's got 1 out of 5 cards is going to be the probability for C. Okay. If she had picked a B first, she can still get A, B or C. Now if she picked a B first, there's going to be 3 out of 5 cards going to be an A. If she picks a B first, now there's only 2 out of 5 that's going to be a B. If she picks a B first, there's still 1 out of the 5 cards is going to be a C. And finally, if she picks a C first, she can either get an A or a B. She cannot get a C as there's only 1 C card. So if she'd picked a C first, 3 out of 5 would be an A, and 2 out of 5 would be a B. Okay. Now it says work out the probability that there are different letters on the 2 cards. Different letters on 2 cards. So do we want probability of AA? No. Do we want the probability of AB? Yes. So we want this one. Do we want the probability of AC? Yes, we want this one as well. Probability of BA? Yes. Probability of BB? No. Probability of BC? Yes. Probability of CA? Yes. Probability of CB? Yes as well. So we've got to work out those probabilities by multiplying through and then adding all these probabilities up to find the probability that the 2 letters on the 2 cards are different. Okay, so let's do it then. It's a little bit long-winded, but it does work. Okay, so let's do it. Probability AB first of all. It's going to be 3 out of 6 times by 2 out of 5. So that's 6 out of 30 is probability of AB. Probability of AC is going to be 3 out of 6 times by 1 out of 5. So that's going to be 3 out of 30. Now I'm going to change colour. So probability BA next. It's going to be 2 out of 6. I hope I've done this right. 2 out of 6 times by 3 out of 5. And that's 6 out of 30. Probability of BC is 2 out of 6 again times by 1 out of 5. And that is 2 out of 30. Okay. And finally, probability of CA first of all, and that's 1 out of 6 times by 3 out of 5, so that's 3 out of 30. And last one, probability of CB, that's 1 out of 6 times by 2 out of 5, and that gives you a probability of 2 out of 30. So the final bit then is the easy bit. You need to add up all of these probabilities that we've that we want. Okay, so let's do it. So 6 add 3 is 9, 9 add 6 is 15, 15 add 2 is 17, 17 add 3 is 20, add another 2 is 22 out of 30. So 22 out of 30, or 22 30ths, is the probability that Rebecca will get 2 different cards. Okay, and that is the final answer. That is the final answer. So I'll just write that on its line as well. So 22 out of 30 is the final answer. Now, if you didn't want to draw a tree diagram out, or you want to do it the quicker way, let's say, not easier way, is you could have done this. You could have worked out the probability of AA. Okay, so you would have done 3 out of 6 times by 2 out of 5. That would have given you a probability of AA. Add the probability of BB, and taken that away from 1, and that would have given you 22 out of 30 as well. Okay, now this is a big 4-mark question. Let's see where you get those marks from. Okay, so if you go down to the calculations, the first 3 are method marks. Okay, so the first method mark comes from seeing any of these multiplying through the branches to get you these probabilities at the end. Okay, any of those will do. You actually get another method mark for timesing these through, okay, with the correct probabilities, especially the second probability here. Okay, that's actually out of 5. So if you've done any 2 of these correctly with the right probabilities, you get 2 method marks. Okay, in total. Now, the third method mark comes from, I haven't written it out, for adding all these probabilities up. Okay, and the fourth final mark comes from the correct final answer. Okay, so 4 marks for question 14, and that's it.